Hi friends, in this video we will see principle of operation of silicon controlled rectifier SCR. So this is basically PN type of structure. Okay, it has four layers. One is P, N, P and N. It has three junctions, J1 in between P and N, and in between N and P, J2 will be there. In between P and N, J3 will be there. So it has four layers and three junctions. So four layers and three junctions. Then what will happen? So there are three terminals also there. One is anode, cathode and gate. Okay, they are connected in this way, and the circuit is connected to power supply. For example, if anode is given to positive and cathode is given to negative, I mean if it is connected like this, so what will happen? So definitely in general, whatever voltage we are providing, I mean huge electric voltage has to be provided to make this circuit to, I mean make this switch to operate. But if you provide some gate voltage, it is you can provide less voltage from anode to cathode, so that your switch will be turned on. Okay, so this is the concept. So with this concept we can go ahead, but the gate, so a low gate voltage gate current can be given to gate to cathode. Okay, and here also we are giving some, we are providing some voltage so that we are giving some current. So normally gate is provided at P layer, so which is needed to the cathode, so that's why this is called cathode gate. So let me consider the things. If positive is connected to anode and negative is connected to cathode, so what will happen? So this is called forward bias condition, I mean for the entire thing. And if this is the case, J1 means it is the P and N, so P is connected to plus and N is connected to minus at the end. So that's why J1 is forward bias, and even you can see J3 is also forward bias. So these two are in forward bias and J2 is in reverse bias. Okay, as J2 is in reverse bias, it doesn't allow any significant current. Okay, this part we know because this is, we have studied in the diode, operation of the diode only. So because of this fact, in forward biased condition SCR doesn't conduct. So I can write like this. So SCR doesn't conduct in forward bias condition. Simply SCR doesn't conduct in forward bias condition. So this particular thing is called forward blocking state or offset of the device. So I can write it here, this is the forward blocking state. So even though I am providing the forward voltage, so the device is blocking the current, blocking state. And same principle which we can apply for in the reverse direction. Same principle if I apply for reverse direction, that means if I provide negative terminal to anode and positive terminal to cathode, what will happen? Okay, that means this part is negative now. Okay, this part will be negative now and this part will be positive now. So what will happen? Negative is touching P, okay, and it touching plus. So what will happen? J1 will be in reverse bias. Similarly, J3 is also in reverse bias and J2 is only in forward bias. So here also J3, J1, J3, they also don't allow any current to flow through it. So definitely this is also not a conducting. So we can again write, so this is also a blocking state, and this is called reverse blocking state. So reverse blocking state. So here we have to know something regarding the depletions and regarding the junctions. So the width of depletion layer at J2 decreases with increase in the voltage across anode and cathode. So what exactly happens, if you can see properly, if for example there is a chance for it to make it on in forward bias condition, plus and minus. So what happened in forward bias condition means, in forward bias condition, J1 junction is forward bias, so the depletion region is like this, very thin, it will be like this depletion region. Coming to J2, the depletion region is wider because it is in reverse bias condition, and J3 is also forward bias, so depletion region is very thin. For example, if I have increased this voltage, so VAK voltage, if I have increased this voltage, what will happen? So if I increase the voltage, so this will be okay, that means this depletion region will be broke out and current can flow through this junction, and this particular thing will become wider and wider, and finally there is a one particular stage where it can be breakdown at this stage. So immediately current will flow through this junction. Similarly, this is also very simple. J3 is in forward bias, so limited voltage is sufficient. But for J2 junction, we need more and more voltage. So this is the one method of turning it on. If you give more voltage, it will be on. Then what we can do it? This breakdown is called avalanche breakdown, and since J1 and J3 are forward bias, so there is a free movement of carriers across three junctions now, so resulting a large amount of current to flow through the devices. So this is what exactly happened in conduction of SCR. Now this is called conducting state or on state of the SCR. Now it is called conducting state. When the SCR will conduct, when we are increasing VAK so that it will be more than VBR of J2. For example, VBR of J2 may be breakdown voltage, may be some hundreds or some thousands. Then if you can provide more than that, then it will be easily broke down, and finally current will pass through this switch. So this is called conduction state. So now without this also we can go ahead. I mean, there is some other method, so with that method we need to proceed. So with this I can conclude this video. So this is regarding principle of operation of SCR. It is very simple. So to conclude this video, this part is very simple. So whenever this particular silicon control rectifier is a 4-layer structure, PN, it has 3 junctions, J1, J2 and J3, and it has 3 terminals, anode, cathode and gate. So 3 terminals, anode, cathode and gate. So whenever we are supplying voltage from anode to cathode, okay, if it is positive terminal to anode and negative terminal to cathode, so what will happen? J1 and J3 are in forward bias, J2 is in reverse bias. So because as J2 is in reverse bias, it never allows any current. It is a very small leakage current will flow through the device, okay, almost negligible. So this condition SCR doesn't conduct. Okay, so in this condition is called forward blocking state, because there is no current flowing through the device, significant current we can say. Okay, now if negative terminal is given to anode and positive terminal is given to cathode, J1 and J3 are in reverse bias and J2 is in forward bias. Here also two things are in reverse bias, so definitely there is no current flow. So this part is called reverse blocking state. And coming to the, then when can it be conducted? So this can be conducted in its forward biased condition if you keep on increasing the VAK. Okay, if you keep on increasing the VAK and there is one level where VAK is more than the VBR of the J2. VBR means breakdown voltage of junction J2. So that is only our thing. Even J1, J3 are already forward bias, so limited amount of voltage is sufficient for them to break down. And for this breakdown of this junction J2, it takes more and more voltage. So because of that, we need to provide more and more voltage, which is just more than VBR of J2. Then the current can flow through the device. Okay, now in the next video we will go ahead with the VI characteristics of the SCR, where we can discuss in more detail in which way we can get this operation little earlier. That means we can apply a little amount of VAK when compared to this condition to make the SCR to conduct easily, okay, by using gate cathode voltage. That we will see in the next video. So thank you for your careful listening, and please like this video and share this video with your friends and family, and kindly subscribe to my YouTube channel. Thank you so much.